Hey everybody, today we're going to take a look at some examples of one-to-one functions and their inverses, and we'll also take a look at composition of functions as a result of that. So let's get going on this. I'm going to share the screen. This in your uh, news items today. Here are some examples of uh, inverse functions and uh, finding the inverse. So let's take a look at finding the inverse first. So we have f of x equals 4x minus 9. We're going to find f inverse of x. Remember this f minus 1 power, that's the symbol for inverse functions. Okay, it's not 1 over f of x, or it's not an exponent. It's telling you it's an inverse. It's the opposite of 4x minus 9. It takes you back to the domain that we started with. So the first thing we do is we rewrite the f of x as y. And we have y equals 4x minus 9. Second thing we do is we switch out the x's and y's. Okay? So y becomes x and x becomes y. So we have x equals 4y minus 9. The third thing we do is we use algebra to isolate the y. So to do this for this problem, I add 9 to both sides and get x plus 9 equals 4x. Then we divide both sides by 4 and get x plus 9 over 4 equals y. Once you have that y isolated, that y is actually the inverse function of f. So f inverse of x equals x plus 9 over 4. A second example would be f of x equals 3x squared minus 9. And we're going to find f inverse of x again. So again, we go through the same process, exactly the same. We replace the f of x with y, switch out the x's and y's. So x becomes y becomes x. So we have x equals 3y squared minus 9. Now we're going to isolate the y like before. We're going to add 9 to both sides and get x plus 9 equals 3y squared. We're going to divide both sides by 3 and get x plus 9 over 3 equals y squared. We're going to square root both sides. This gives us the square root of x plus 9 over 3 equals y. Now we don't minus the square root of both sides because we want the 3x squared minus 9 to be a one-to-one function. If we included the negative square root part, it would not be one-to-one. Okay? And so we get this for the inverse. That's one form. Chances are they're going to simplify that on us. So the first thing we're going to do is we're going to rewrite the square root of x plus 9 over the square root of 3. Remember, with square roots, you can take the square root of the top and bottom separately if we have a fraction. Then we're going to rationalize by multiplying both sides, both top and bottom rather, by whatever's in the denominator. So in this case, it's square root of 3. Multiplying out this 3 is under the square root, so it can go in with the x plus 9. So we have 3 times the quantity x plus 9 under the square root in the top. And then these two 3's can be multiplied together, giving us square root of 9, which ends up being 3. So the simplified version of our inverse function is the square root of 3 times the quantity x plus 9 over 3. When we have a rational function, it's a little bit trickier to find the inverse. So let me scroll up here a little bit so we can have that more clearly in view. Went a little too far there, sorry about that. There we go. So we have f of x equals x over x plus 3. Find f inverse of x. So again, we're going to go through our process. We just have to keep in mind how to solve things that have rational expressions or functions involved. Okay? And so one thing we have to keep in mind is the lowest common denominator. When we're solving for something that has a fraction involved, we're going to multiply both sides by the lowest common denominator eventually. So we get y equals x over x plus 3. We switch out the x and y's. This gives us x equals y over y plus 3. Now we're going to multiply both sides by y plus 3. I need to break this fraction up. Okay? So that gives us x times the quantity y plus 3 equals y over y plus 3. The y plus 3 times the y plus 3. The y plus 3's cancel on this side, giving us just y left here. On this side, we get the x times the quantity x plus 3. So we end up with x times the quantity y plus 3. I said x, but it's y plus 3 equals y. Okay. Now distribute the x and get xy plus 3x equals y. Subtract 3x from both sides Move the y over to this side. In other words, we're going to group the y's on one side, all the terms without y on the other side. And so this gives us xy minus y equals minus 3x. Now we're going to factor the y out of here. That's kind of the trick, if you will. It's not really a trick because we use it over and over again. It's not a math trick, it's a standard practice to factor out common factors, and that's all we're doing here. But people always think it's the trick here. Okay, so we factor the y out, and that gives us y times the quantity x minus 1 equals minus 3x. Now we're going to divide both sides by x minus 1. So this gives us y equals minus 3x over x minus 1. So that's our inverse. Now we're going to test to see if a couple of these are actually inverses. Recall, the test for inverses, if f of x and g of x are one-to-one functions, at least in their given domain, and f comp g of x equals g comp f of x equals x, so take the composition of both ways in both arrangements and it equals x, then they're inverses. Okay? So let's start with the first one. F of x equaled 4x minus 9, and g of x equaled x plus 9 over 4. Okay? So I'm going to take f comp g of x. Now remember, f comp g of x from the handout I gave you yesterday is f of g of x. So that means every place we see an x in f of x, we'll replace that x with whatever g of x is equal to. So that gives us 4. And remember, x was here for f of x. So that gives us 4 times x plus 9 over 4 minus 9. This 4 and this 4 are common factors. They can be reduced out because this 4 is in the numerator, that one's in the denominator. And that gives us x plus 9 minus 9, which equals x. So that's the first step. If that didn't equal x, we'd be done. Okay. Second step, take g comp f of x. Now remember, g comp f of x is the same thing, again, based on the handout we saw yesterday, is g of f of x. So that means every place there is an x in g, so the x is right here, in g, I'm going to replace it with 4x minus 9. So that was x before. So now it's 4x minus 9. So that gives us 4x minus 9 plus 9, which gives us 4x over 4. Dividing out the 4's give us x. If that didn't equal x, we'd be done. Okay? Even if the first one equaled x and the second one didn't equal x, we'd be done. They're not inverses. But since both of these equal x, they are inverses. So that's our conclusion here in step 3. Now, just like when we were finding the inverse up here for x over x plus 3, testing it out is more difficult too when it's a rational function. Let's take a look at how we do this. We should do this at least a couple times, I suppose, in our algebra lives. So f of x equals x over x plus 3, and g of x is minus 3x over x minus 1. So the first thing we're going to do is we're going to take f comp g of x, which again is f of g of x. So that means every place there's an x in f of x, I'm going to replace it with this function minus 3x over x minus 1. That's going to give us fractions over fractions, or complex fractions sometimes they're called. So let's recall how we handle this. Okay, so the first thing I know is there's not much to do in the top. There's no adding or subtracting in the numerators I have to do. There's no separate fractions in the top. Okay, in the bottom though there is. We have a minus 3x over x minus 1 plus 3. So I'm going to have to add that minus 3x over x minus 1 plus 3 together. To do that, I need to find a common denominator. And the common denominator would be x minus 1. And so x minus 1, finding the common denominator means I have to multiply the 3 by x minus 1 and the denominator of 1 down below by x minus 1. That gives us this fraction right here. Okay. And so now we have an x minus 1 in each denominator. We'll go ahead and add numerator with numerator. So minus 3x plus 3 times the quantity x minus 1 over the common denominator. We'll distribute the 3, giving us minus 3x plus 3x minus 3 over x minus 1, which ends up being equal to, and goes on to the next page, minus 3 over x minus 1. So now putting that back in, we end up with minus 3x over x minus 1 over 3x over x minus 1 plus 3, becoming minus 3x over x minus 1 minus 3. Don't know why I put a 9 there. Typo there. Sorry about that. Over x minus 1. Now, this is a fraction over a fraction. We have a fraction over a fraction. Remember, the fraction bar means to divide. So we take the top fraction and divide it by the bottom fraction. So this gives us then minus 3x over x minus 1 divided by minus 3 over x minus 1. Now let's recall how we divide. We saw that a couple weeks ago. We copy the first fraction, change the division to multiplication, and flip-flop the second. So remember, copy, dot, flip-flop. Divide out the minus 3's and the x minus 1's because they are common factors, and that leaves us with x. So that part's okay. Now we'll do g comp f of x, which again is still messy. In fact, it's even a little bit more messy because we have to actually multiply this minus 3 with the x over x plus 3 in the top. That gives us minus 3 over x plus 3. And then in the bottom, we have to do the same thing, except we're doing it with x plus 3 as a common denominator. And we're subtracting. So when we find the common denominator, we have to multiply this 1 over 1 by x minus 3. That gives us minus x plus 3 over x plus 3. And now we take numerator minus numerator, making sure we put parentheses around that numerator in the second after the subtraction over the common denominator. Distributing the negative gives us x minus 3, or minus 3 over x plus 3. So minus 3 times x plus 3 over x plus 3 x over x plus 3 minus 1 equals minus 3x over x plus 1 over minus 3 over x plus 3. Now we're going to do the same idea. We're going to copy the first, we're going to multiply, and we're going to flip-flop the bottom. And so that gives us x. So again, since f comp g of x equals g comp f of x, f and x have to be inverses. I should put g comp f of x there. Sorry about that. And we'll fix that when I send it out. Have a good day.